Hey guys, so today we're going to continue on writing, interpreting algebraic expressions, which is what we started yesterday. So I'm on page 73 here, and we have our expression or example here about Noah and how many books he reads. He reads a book and an article. The article is 12 pages long. He completes all the reading in 8 days, and he reads the same number of pages each day. Write an algebraic expression for the number of pages Noah reads each day. So here they're using b as their variable to represent the unknown number. And then he's going to add to write an expression for the total number of pages Noah reads. So b plus the number of pages in the article. So there are 12 pages in the article. So it'd be b plus 12. But then he's going to read that over 8 days. So then we're going to divide by 8 to show that he's has an unknown number of pages in the book, but he reads, the article is 12 pages, and then we're going to divide that over 8 days. So that is why this is the end result of the expression. Okay, let's look at Julio. So Julio says that the expression b plus 12 divided by 8 in the example right here can be written as a fraction, b plus 12 divided by 8. Do you agree? Okay, so you should agree, right? Because that's true, yes. So I'm going to go ahead and put yes. Sometimes it does this to me, and I'm not sure why. Yes, I agree. Now, why do we agree? Why do we agree? That's the next question. Because a fraction has the same value as division, right? So let's go ahead and put that. So fractions can be represented as division. All right. Okay, number 2. Write an algebraic expression for each word phrase. So 5 less than 3.1 times a number n. Okay, let me get my drawing tool here. So we have 5. So let's start with 5. Less than. What does less than mean here? What does less than mean here? It means to subtract. Yep. So we're going to subtract. Less than 3.1. So I'm going to put 3.1 times a number n. So there's a couple different ways that we could do this. So we can do times the number n. But then if that's the case, I would definitely want to put this in parentheses to separate it, okay? Or, so let me put a little or here. We could do it as 3.1n, okay? 3.1n. So one thing though, I want to check here real quick. It says 5 less than 3.1. So that means that this is going to be bigger. So let's go ahead and put it first. So it'd be 3.1 n minus 5. Okay, so that's actually the expression based off of this word phrase. And remember, whenever we have it, if it's times a number, we can always put that letter next to the number, okay? Because that means to multiply in algebra. Okay, number 2, 4 more than the quotient of 12 and a number x. Okay, so we have 4 more than. So what does more than tell us to do? It tells us to add, right? So we're going to add the quotient of 12 and a number. Okay, quotient, what is quotient? The answer to a division problem, right? So that means because I want the answer of this before I add 4, I'm going to put it into parentheses here. So the quotient of 12 and a number. So that means it's going to be 12 divided by x. And they're using x as the variable here for the number, okay? So what's another way we could write this? So I just want to hit or here in case, because not everybody writes it the same way, right? We read things in different ways, but I want to make sure that we're understanding how to write an algebraic expression. So another way is, because we just talked about how fractions can be represented as division, let's go ahead and put this in fraction form so that we know that it means the same thing to divide. So when it's looking for a quotient, it's going to be the same thing, okay? So we have 12 divided by a number, and then we can add 4. So this would just be another way to write it, because we're still showing that it's division here, and then we add 4. Okay, number 3. Ava has a part-time job at a store. She earns a weekly salary. She also earns 60 cents bonus for each gift card she sells. The expression 165 plus 60 cent G, or 0.60, right? G, shows Ava's total weekly earnings. Identify any variables, coefficients, and terms in the expression. Tell what each represents. All right, well, let's go ahead and start with our variable here. Let me make this smaller since we have a lot to write. Okay, so let's start with our variable. What is the variable in this expression? G, right? G is the variable. And what does that represent? It represents unknown number. For unknown value. Okay, so G is the variable here. So the next one was coefficient. So what is the coefficient in this expression? Let me use my drawing tool so I can underline the expression so we could better see it. There we go. So what is the coefficient here? 0.60. That's the coefficient. Now, why is that the coefficient? Because that is the bonus that she gets for selling the gift cards. And as we know, it is attached to the variable. Okay, so let's go ahead and put that. It represents the amount she earns per gift card. Okay, next is terms. How many terms are in this expression? If you said 2, you're correct. 2 terms. Okay, so what are the 2 terms? So the first term is 165, and the second term is 0.60G. So those are our 2 terms, okay? So our 2 terms are represented in that way. All right, that's all we had to do for number 3. Let's move on. Okay, number 4. Dario looks at the parallelogram and writes the expression x plus 3 and 9. Is Dario's expression a sum, a product, a difference, or a quotient? So what is his expression? What do you guys think? Do you think it's a sum, a product, a difference, or a quotient? Let's see, text box, there we go. It is a product. Yes, it's a product. Okay, why is it a product? It's a product because here, parentheses around the 9 tell us that we are going to multiply, okay? So the parentheses tell us we are going to multiply, okay? All right, part B. What are the factors of the expression x plus 3 and 9? What does each factor represent about the parallelogram? Okay, so if we're multiplying, that means we're multiplying two things, right? So what are the two things that we're multiplying? What are the factors? Okay, so let's put factors here. So what are the factors? What are the two things that we're multiplying together? Well, we're multiplying x plus 3, so that's 1. And the second factor is 9. Those are the two factors that are being multiplied. So what does each factor represent from the parallelogram? So let's go back up to our parallelogram here. So obviously the 9 then represents what? The height. And the x plus 3 represents the the base. Okay, so let me just continue on this one. 9, okay, so let me start this over. The 9 represents the height of the parallelogram. And the x plus 3 represents the base. Here we go. Okay, part C. What does the expression x plus 3 times 9 represent? So when we're looking here at the parallelogram, if we are multiplying the height times the base, what are we then looking for, you guys, in the parallelogram? What are we looking for? We're looking for the area, right? So x plus 3, let's put that in parentheses, x plus 3 times 9 represents the area of the parallelogram. Okay? Well, that's pretty much it. I mean, why? Because it shows us the height and the base. Okay. So there we go. Number 5. 3 friends go to a restaurant. They share a meal. They decide to split the cost of the meal equally. Each friend also contributes $2 for the tip. Write an algebraic expression for the amount each friend pays and show your work. Okay, so let's go ahead and start with having a variable, right? So we're going to use, let's use M for meal. Okay, so M, that is going to equal the meal. Okay. And then let's see, it says then they all contribute $2 to the tip. So let's put that down here. So then they're going to contribute, so they're going to add $2 for the tip. Okay, but each person is going to add the $2 to the tip. So that means so if there's 3 people, That's going to be 2 times 2. No, 2 plus 2 plus 2. Okay. So if each person is going to pay, let's say, a third of the cost then, because they all share one meal, and this one meal is going to be split into 3 ways. Okay. So that means that if each one is going to be, let me do a visual actually. So here is our meal. Okay, I'm going to make it into a rectangle here. And it's going to be split into 3 different ways. Okay, so person 1, person 2, person 3. That means each person is going to have 1/3 of the meal. So let's go ahead and write that. So 1/3 of the meal. Okay, but then they're going to add $2. Each person is going to add $2. So one person is 1/3 of the meal plus the $2 for the tip. So here's our algebraic expression. So it's 1/3 m plus 2. Here's another kind of challenge way, an extended way for those of you who are at that spot. But to give you another version, we could put it as m over 3 plus 2. That is an extended version. And how did we get that? So anything times 1 is itself. So m times 1 would be m. So we could do it as m over 3, which is the same thing, right, as this, plus 2. But whatever makes sense to you, okay? So honestly, this makes more sense to me. So this would be the expression that I use. Okay, number 6. So I'm going to set you up for this, but you will go ahead and answer this on your own. Leah runs m miles every day during the week, except for Wednesday and Sunday. Write an algebraic expression that represents the total number of miles Leah runs each week. So there's 7 days in a week, but she doesn't run Wednesdays and Sundays. So then how many days is she actually running? Okay, think about that. And then it says there are 52 weeks in a year. So write an algebraic expression that represents the total number of miles Leo runs in a year. So you're going to take this portion and then you're going to include this portion for part B. Okay, so part B is going to be A included with B. Again, I hope this kind of helps you out a little bit so that you can kind of understand how to write algebraic expressions and understand them a little bit more. We want to make sure that you know their terms for algebraic expressions: coefficient, variable, term. Trying to think if there's another math lingo, and I can't think of it right now. But we'll continue working on this week. And then I won't have office hours today, but if you have questions, you can always talk to me about it on Thursday. All right, guys, thanks a lot, and I will see you soon.